Hi folks, I realized, actually, so student helped me realize that I may not have given you two formulas necessary for one of the quizzes. So here we are back at the difference of proportions or diff prop sheet, which I've included in a sheet which will be called Glacier JEB Latest, which I'll post on Moodle. And we created this little sheet here to do the difference of proportions test, and we ended up with our z value here, which was our P1 minus P2 over the square root of P1 times 1 minus P1 over N1 plus P2 times 1 minus P2 over N2, which we copied and pasted. Yours might look slightly different. I've added this formula sheet here, and that creates a z value for us, and I said, well, that was bigger than 2. Well, the p-value for that is the formula norm s dist, which we could have just started typing equals norm, and that's normal, and it's the normal distribution, and our z is normally distributed. And we selected our E14, which was the z value that we got, and we put true, so it gives us the end of the tail distribution, and we see that 0.0000126, and it's pretty darn small, and that's what gives us our p-value for the difference of proportions. So you'll need to know that formula for the difference of proportions. All right, so here we go with the second one that you're going to need. And I did a pivot table, which we did before in class, where I do fish and whether it's greater than the median. And this is for our gills. And then we put the count down here, so it gives us a frequency table. So there were 62 who were less than the median in ponds with fish in them, and there were 58 less than the median with no fish, and 38 and 82. So we see the larger number here. I simply select these and I do a Control C, and then I come over here and I pasted them special as values because I wanted to get rid of the formulas. And then an edit and paste values, or a right click and paste values. Either one of those will work. Paste 1, 2, 3. And so there we have the same chart that was over here. I just have it here as labels. Now we want to do the sort of what are called marginal expectations here, and that's the row and column totals over the total. So it's 100 times 120 over 240, which gives us an expectation of 50. And you'll see that's the same formula here. And we have 70 and 120 and 240. They're symmetric, so we end up with 50 and 70. And those are our expected values. So these are what we saw. We would have expected, based on these numbers, to see 50 and 70 and 50 and 70. We didn't. We saw 62 and 58 and 38 and 82 above and below the median. This is the true moods medians test. And then we create these values, which are the observed, which is 62, minus the expected, which is 50, squared over the expected, or observed minus expected squared over expected, and that's this formula. If we click on it, you'll see that it's that minus that over that, so it's in there twice. And it's the same for the next one, and it's the same for these, and we end up with the same chi-square values. Then we sum the chi-square over all of those that we did for every single square, and then we do a chi-square test on all of these. There's two ways to do it. One, we could have just selected those two and used the chi test to calculate it, or we could have done 1 minus chi dist, which is this 9.8 value. If I click on that, you see that it's 1 minus the chi distance for that Q7 value, and that will give us the right tail, or the significance value. So this, I should type in chi square, and we'll do p-value here. I just did it in two different ways to show you could have just used the chi-square test between two different tables, but this is the one you needed for, well, for the exam. So I hope that solves that one for those of you with questions.